Before a single passenger boards, before the engines start, before the doors even close, two pilots are already deep into a checklist that has been refined over decades of aviation safety. What happens inside that cockpit in the hour before you fly is one of the most methodical processes in any profession. When pilots arrive at the aircraft, it is already being prepared by dozens of people. Ground crews are fueling the tanks, loading baggage, catering the galley. But the pilots step straight past all of that and into the flight deck. Their first task is not to start anything. It is to inspect. The pre-flight walk-around on larger commercial jets is typically done by the first officer. They circle the entire aircraft looking at tires, checking for fluid leaks, inspecting flight control surfaces, examining the engines for any signs of foreign object damage or bird strikes. Every dent, every scratch beyond certain limits gets written up. Nothing gets assumed. Meanwhile, inside the cockpit, the captain is beginning the first formal checklist of the day. Seats are adjusted. Oxygen masks are tested. Circuit breakers are scanned. Every instrument, every display, every switch is verified to be in its expected position before any power is applied to the aircraft systems. Once external power is connected and the avionics come alive, the pilots turn to the flight management system. This computer will essentially run the navigation for the entire flight, but it knows nothing until they tell it everything. They load the departure airport, the destination, the alternate airports in case of diversion, the runway they expect to use, the departure procedure. A precise coded route that gets them from the runway into the en route structure safely and without conflicting with other traffic. Then comes performance data. The FMS needs to know the aircraft weight. Every kilogram matters. It affects how long the takeoff roll will be, which speed the nose lifts off the runway, how steeply the aircraft can climb after takeoff. This data is cross-referenced with independent performance cards. If the FMS calculation and the paper calculation do not match within a small tolerance, they do not take off until they understand why. From the performance calculations come the V-speeds. Three critical numbers that pilots set on their airspeed indicators and memorize before they ever move. V1 is the decision speed. Above this point, if something goes wrong, the pilot must continue the takeoff because stopping is no longer guaranteed to work within the remaining runway. VR is rotate speed, the moment the pilot pulls back on the controls and lifts the nose. V2 is the takeoff safety speed, the minimum speed that guarantees control and climb performance even if an engine fails immediately after liftoff. These numbers are not rough guides. They are calculated precisely for that aircraft, on that runway, at that weight, in those atmospheric conditions on that day. Once the speeds are set, the departure briefing begins. The captain talks through the entire takeoff procedure out loud. Which runway, which departure route, what altitude to expect, what the weather is doing, and critically, what happens if something goes wrong. The engine failure procedure, the return to land procedure, the emergency contacts. A briefing that sounds routine contains the contingency for the catastrophic. Aviation learned decades ago that human memory cannot be trusted for safety-critical tasks, regardless of experience. Pilots who have flown the same aircraft for 20 years still read from a checklist before every single flight. The before start checklist confirms the aircraft is configured correctly before the engines are started. Fuel selectors, hydraulic pumps, flight controls tested for correct movement. Start the engines and the after start checklist runs through engine parameters, electrical systems, pressurization settings. Then the before takeoff checklist at the holding point. Flaps set, trim set, transponder on, lights on. Every item is called and responded to by the other pilot. The call and response format is not ceremonial. It is a cognitive check that forces both pilots to actively verify each item rather than letting one crew member work through it alone. Studies have shown that two people completing a checklist together catch significantly more errors than one person working alone. As the aircraft approaches the runway, the crew enters what pilots call the sterile cockpit. Non-essential conversation is prohibited. ATC communications are handled formally. The focus is absolute. At the runway threshold, one final check. Is every item on the before takeoff checklist complete? Is the takeoff clearance received? Is the runway clear? Are all systems showing normal? The thrust levers advance. The aircraft accelerates through V1, through VR, the nose lifts. V2, the aircraft climbs. For passengers in the back, the flight has just begun. For the pilots, they are already executing the third or fourth checklist of the day. Every step that seemed routine was protection against the failure nobody expects, on the flight nobody thought would be different from any other. These procedures are not bureaucracy. They are the accumulated lessons of every accident investigation, every incident report, every near miss that aviation has experienced and learned from. The pre-flight process exists because the alternative, flying on assumption and memory, cost lives before this system was built.